if you look at the history of life on Earth, then so Earth formed, and it was just there was no life. It was a ball of rock, and almost as soon as it cooled down, we see evidence of life. So certainly 3.8 billion years ago, possibly even further back than that, we see evidence of life on Earth. So somewhere along the line, geochemistry, active geochemistry, became biochemistry on Earth. And we have some idea, that if you get gradients of temperature and acid and alkaline and the conditions that are naturally present on the surface of oceans, then complex carbon chemistry spontaneously happens. So we know that life, almost certainly we know that life began on Earth. I mean, the other option is it came from space or something like that, but it probably didn't, right? It probably began on Earth. So that means that at least here, that happened. And that we know that the conditions that led to the origin of life on Earth were present on Mars 4 billion years ago. And we know that they're present on Europa today. So I don't see that there's anything special. Life is just chemistry. And the idea that geochemistry becomes biochemistry is not fanciful because it happened here. So I think that given the same conditions, it would be surprising to me if the same thing didn't happen, in that life begins. So that's to test that is one of the great frontiers of science now. It's one of the great challenges, which is why another reason we're interested in Mars, because we know those conditions were there. We know there were what's called hydrothermal vent systems on the floors of oceans on Mars 3.8 or 4 billion years ago. So it would be good to know if what I've said is right. And the way we find out is to find life or evidence of past life.
Are you aware of the speculation that was going around? How recent was it, that Occupy thing, the octopus eggs? There was a group of scientists that were speculating that it's panspermia, the idea of panspermia, that it's possible that octopi had come from somewhere else. Some frozen eggs had actually come from somewhere else and landed on Earth. And these were like legitimate scientists that were contemplating it, not morons.
I don't think...
Have you seen this?
No, I didn't. But I mean, I think it's unlikely. So panspermia doesn't have to be unlikely.
Right.
I mean, for example, you might have seen the other day we found an Earth rock on the moon.
Yes.
Right. Well, it was back on Earth now because the Apollo astronauts brought it back, didn't they? It's 4 billion years old or something like that.
One of the oldest rocks ever found.
Yeah.
Right.
So we know that material gets transferred between planets. And so it's not inconceivable that microbes could survive that journey. Right. We know that microbes can survive in space, for example. So that isn't mad. It's probably unlikely, but it's not mad. But with the octopus, I hadn't heard that. But the thing is that the octopus is still extremely similar biologically to us. I mean, the differences are negligible.
Yeah.
So it's still got the same energy system with this thing called ATP and DNA and all that stuff. It's all very, very similar.
It was something about RNA and DNA. Did you find that article?
I'm looking at a different one from a different website. It's about the same thing. It has to do with the Cambrian explosion. And there were 33 authors on a paper that got published in the Progress in Biophysics and Molecular Biology that talked about this possibility. There are other people that disagree with it, though.
Right. I mean, I suppose I haven't seen it. So I think it's unlikely because the octopus is extremely similar to us. So that suggests a common origin to me. That I suppose the counter argument you could advance would be there's only one way to do life. So you could say that actually because the laws of physics and chemistry are the same everywhere. So maybe DNA is the only way to do it. So that's the way it gets done.
Which is why they're so similar to us. Yeah, so although so alien as well.
Yeah, they're not, though. That's the thing about an octopus. That's why I'm surprised about it, because they're not that alien. They're very similar.
Well, they're in their abilities. I mean, their ability to transform their outer texture and their color almost instantaneously.
Oh, yeah.
I mean, they have incredible camouflage abilities that really don't exist in the mammalian world.
Yeah, but on a cellular level, you look at an octopus cell under a microscope, and you wouldn't be able to tell the difference between an octopus cell and a human cell.
So the only way that would make sense is if all life comes from basically the same kind of building blocks and just varies depending upon the conditions and where it takes place.
I'm guessing, but yes, that must be the only way you could sustain that, given that they're so similar to us, because they really are, biochemically, is that's the only way can be done, given the building block, the toolkit, the laws of nature, and the elements and so on that we have in our universe.
We have so many different life forms on our planet, but if we found anything that's remotely similar to what we have here on Earth on another planet, it would be such an incredible discovery. Like if we found a frog on the moon, I mean, the world would stop, right?
I'd be very surprised if we found a frog on the moon.
But I mean, if we found anything anywhere that is in any way similar, an insect on Mars.
Well, this is, I mean, as I say, it'd be micro. I think it'd be single-celled things. Remember, I mean, you mentioned the Cambrian explosion. So that is, what we do know about Earth is that although life began, let's say, 3.8 billion years ago, it wasn't until around 600 million years ago or so, or maybe at most 700, that you see any complex multicellular organisms at all. So for something like 3 billion years, it was single-celled alone. And that's one of the reasons why I would guess, if I had to guess, I would say that microbes would be common because life began very quickly on Earth. And I wouldn't be surprised if we find it on Mars. But complex life, multicellular life, insects, plants, intelligence, I would guess will be very rare because it took so long on Earth to get there. And it was just slime. About 3 billion years of slime. That was it.
What happened? How did it go from slime to giraffes?
It did it very quickly once it got going.
Yeah.
And it's one of the great unsolved mysteries in biology. That one thing that is true is that we seem to be, all complex creatures seem to be, we're called eukaryotes, right, which is cells with a cell nucleus and all that kind of stuff. And they look like they're the merger between two simpler life forms, bacteria, and a thing called an archaean. So it looks like somewhere in 2 billion years ago, whatever it was, in some ocean, the bacterium cell got inside the archaean and survived as a symbiotic organism, essentially, and then somehow, unbelievably, managed to reproduce and replicate in that configuration. And that does seem to be the origin of all complex multicellular life on Earth.